Hello viewers, in today's session we are going to discuss one important and conceptual problem from differentiability of functions. And in this class we are going to discuss this problem in which we have to discuss the differentiability of this mod function, that is f of x is equal to mod of x plus 3 at this point, that is x is equal to minus 4. Right now, see, the modulus function is a continuous function for all real numbers, but it is not a differentiable function. Right, suppose we have a modulus function of this type, say f of x is equal to mod of x plus a. Right now, this mod function is continuous for all values of x, but this mod function is not differentiable at this point, that is x plus a is equal to 0, that is x is equal to minus a. Right, so for this point x is equal to minus a, this function is not differentiable, but it is continuous at this point x is equal to minus a. Now if we have the function of this type, say mod of x minus a, then this function is continuous for all values of x for real numbers, and this function is not differentiable at this point, that is x minus a is equal to 0, that is x is equal to a. Right, so in this problem we have the function mod of x plus 3. So this function is continuous for all values of real numbers, but this is not a differentiable function at this point, that is x plus 3 is equal to 0, that is x is equal to minus 3. So this is the only point where this function f of x is not differentiable, and it is differentiable for other points. Right, so here we are taking this point, that is x is equal to minus 4. So this function is going to be differentiable at this point, x is equal to minus 4. But here we'll see how we can prove that this function f of x, that is mod of x plus 3, is a differentiable function at this point. So the derivative of this function, it exists at x is equal to minus 4, but at x is equal to minus 3, this function is not differentiable. So with the help of the concept of left hand derivative and right hand derivative, we'll prove that this function is differentiable at x is equal to minus 4. So by the definition of differentiability of functions, we know that if the derivative of a function is to exist at some given point, then the left hand derivative must exist and it must be finite. And similarly, the right hand derivative must exist and it must be finite, and both the derivatives must be equal to each other. Right, so if we have a point, say x is equal to a, then the left hand derivative at this point must be equal to the right hand derivative at this point, x is equal to a. So in this case, first we'll find out the right hand derivative, and we'll find out the left hand derivative, and we'll see that both the derivatives are equal to each other. So now let us first find the right hand derivative. So the right hand derivative is given by this notation, that is f prime of a, and here we write a positive sign, and we write limit h tends to 0 f of a plus h minus f of a divided by h. Now here a is minus 4, so we can now write limit h tends to 0 f of 4 minus 4. Here a is minus 4, so minus 4 plus h minus f of minus 4 divided by h. So now the value of f of minus 4 plus h can be obtained by replacing x by minus 4 plus h. So we have mod of minus 4 plus h over here, plus 3, then we have f of minus 4, that is mod of minus 4 plus 3, and here we have h, right? So now this is limit h tends to 0, and 3 minus 4 is minus 1 plus h. Then here we have mod of minus 1, here we have h, right? So now we can rewrite this expression as limit h tends to 0 mod of h minus 1, and mod of minus 1 is plus 1, so we have simply 1 here, and here we have h. So now here we have mod of h minus 1, right? Now from the definition of mod function, see, a mod of p is given by positive p whenever p is greater than 0, and mod of p is 0 when p is 0, and mod of p is negative p when p is less than 0, right? Now see here, we have h minus 1. So if we take p is equal to h minus 1, then h is infinitesimally very small as compared to 1. So h minus 1 is less than 0. So this is a negative quantity. So here a mod of p is equal to negative p will apply this property of or this part of this definition. So mod of p is minus p when p is less than 0. P is h minus 1. H minus 1 is less than 0. H minus 1 is a negative quantity, right? So mod of h minus 1 is equal to negative of h minus 1. That is 1 minus h. So here we have limit h tends to 0, and here we have 1 minus h minus 1 over h. Now this one and this one get cancelled. We are left with limit h tends to 0 minus h over h. So this is the limit h tends to 0, and h get cancelled. We are left with minus 1. So this is minus 1 because this is independent of h. So limit h tends to 0 minus 1 is minus 1. So the right hand derivative of this function at this point is equal to minus 4 is minus 1. So now we can write here f prime of minus 4. Here we write a positive sign, so the right hand derivative is equal to minus 1. So now let us find out the left hand derivative. So the left hand derivative is given by f prime of a. Here we put a negative sign, and this is given by this limit h tends to 0 f of a minus h minus f of a divided by minus h, right? So this is limit h tends to 0 f of a can be replaced by minus 4. This is minus h minus f of minus 4 divided by minus h, right? Okay, so now let us find out the value of f of minus 4 minus h, which can be obtained by replacing x by minus 4 minus h. So we have mod of minus 4 minus h plus 3. Then here we have f of minus 4, that is the mod of minus 4 plus 3. And here we have minus h. So this is limit h tends to 0, and this is 3 minus 4 is minus 1. This is minus h, and here we have mod of minus 1, and this is minus h. So now here we have a mod of minus 1 minus h, right? So again we'll make use of this definition of mod function. So minus 1 minus h is again less than 0, right? Because here we have negative sign, here also we have negative sign, and h is a positive quantity, right? H is infinitesimally very small, but it is greater than 0. So minus 1 minus h is less than 0, that is this quantity is negative. So again mod of p is equal to negative p when p is less than 0. So mod of minus 1 minus h is equal to negative of minus 1 minus h. So this is 1 plus h. So minus minus plus minus minus plus, right? So mod of minus 1 is equal to 1. So now this limit is limit h tends to 0, and we have 1 plus h minus 1 over minus h. So now here we have limit h tends to 0, 1 and minus 1 get cancelled. We have h over minus h, and h get cancelled. So we have limit h tends to 0 minus 1, that is minus 1. So the left hand derivative of this function at this point, that is f prime of minus 4, here we write a negative sign, and this is equal to minus 1, right? So we see that the left hand derivative and the right hand derivative both exist, and they are finite at this point. X is equal to minus 4, and both are equal to each other. So we can write left hand derivative is equal to right hand derivative. Hence the derivative of this function, that is f prime of minus 4, it exists. It means this function is differentiable at this point. X is equal to a, that is x is equal to minus 4, and f prime of minus 4 is given by the common value, that is the left hand derivative is minus 1, the right hand derivative is minus 1. So here we have minus 1. So we can say that this mod function mod of x plus 3 is differentiable at x is equal to minus 4.